Bangladesh is a nation controlled by supremely powerful natural forces. With more than 160 million people, half the U.S. population on 2% of the land, it's the most crowded place on Earth. Bangladesh sits on Earth's biggest delta, miles-deep muddy sediment spread over a vast area, dropped there by the mighty rivers that drain the Himalayas. It's close to sea level, so water is everywhere. Busy waterways can stretch 10 miles across. In rainy season, up to two-thirds of the country floods. People here are mostly hard-working farmers and fishermen. They've always adapted to nature by working around it, occupying the low ground when possible and moving to higher when necessary. But as Bangladesh grows and develops more infrastructure, it's becoming more vulnerable to natural disasters. At the same time, scientists are finding that known natural hazards here may be interconnected in unknown ways. Movements deep below the surface may control the tilt of land, the paths of rivers, and very possibly giant earthquakes that could bring unimaginable destruction to this country. Bangladeshi scientists are working with Columbia University's Lamont Doherty Earth Observatory and other institutions to help unravel these connections so the nation can cope. Bangladesh sits at the nexus of three tectonic plates, all twisting and compressing it in complex ways. The Indian subcontinent, where most of the country sits, is slowly moving northeast. The Himalayas at top rise high because Bangladesh and India are slowly being shoved under them. To the right, Myanmar is slowly swinging into Bangladesh, right along the same tectonic boundary that caused the 2004 Sumatra earthquake and tsunami that killed some 230,000 people further south. Scientists have come to recognize that many earthquake danger zones must extend under Bangladesh and may be building stress right now. But these zones are buried by up to 12 miles of sand and mud, so exactly where they are and how they move is a mystery. The 2004 Sumatra shock, 1,300 miles south, merely stirred up 2-foot waves in the Bangladesh capital of Dhaka. But a closer earthquake in 1762 drowned 500 people on what is now the booming Dhaka riverfront. In the 1700s, Dhaka's population was numbered by thousands. Today, Dhaka is a megalopolis of more than 15 million. New residents migrate in every day, and new buildings, often flimsily built, are multiplying everywhere. Out in the countryside, factories and utility lines are springing up. There are new roads, and seemingly everywhere, new bridges spanning rivers that just 10 years ago could be crossed only by foot or ferry. This blossoming of population and infrastructure means that a big quake, here, now, could be worse than even recent tragedies in Sumatra, Haiti, or Japan.
The risks of the earthquake in Dhaka city is the high in the world because of this poor infrastructure, poor response to earthquake, extremely dense populations. I think Dhaka will be totally a dead city. In one word, you can say Dhaka will be just a dead city. It's a city of a concrete, broken concrete buildings, and it will be really devastating.
The team suspects that related subterranean forces may also shape the rivers, some of which have changed course dramatically over time. Under tectonic pressure, large blocks of land may rise or sink gradually, or in an earthquake, they may move in an instant. Either way, when a threshold in elevation is reached, a river may decide to take a different route. Such vertical movements may have caused the great Brahmaputra River to shift suddenly over 50 miles west around 1800. This switch left its former bed a literal backwater, its trading centers collapsed. Everything in the way of the new bed no longer exists. This kind of massive shape-shifting can happen again. Team members have already employed ground positioning instruments to show that some 100 billion tons of water flooding the land in rainy season actually pushes the underlying crust of the Earth down several inches each year, possibly enough to trigger earthquakes below. Understanding how the surface might affect the deep underground, and how the underground might affect the surface, is key. To investigate these hidden phenomena, scientists are using many methods in a 5-year project funded by the U.S. National Science Foundation. In 2004, Bangladesh had only 2 working seismometers. Now it has 18 deployed in strategic locations, and Bangladeshi staff are being trained to use them. Each year, dozens of small tremors, many imperceptible without instruments, shake the country. Accurate instrumental readings will help seismologists to pinpoint invisible faults from which such tremors are coming and to judge whether these faults could generate bigger ones. Each rainy season, the rivers carry downstream up to 1.5 billion tons of Himalayan sediment. In many places, they lay down sand and mud 10 feet deep. In other places, vast swaths of earlier deposits are swept away. During this season, much of the nation floods. Riverbanks shift, huge islands form, disappear, and reform elsewhere. This constant supply of new soil is what makes the country so fertile. The constant removal is what makes it so perilous. Many people, like those living on this transitory island, move constantly just to keep up with the land. The scientists looked for places where layers of sediment had built up over tens, hundreds, or thousands of years. These layers tell the history of the landscape like pages in a book. Sudden changes in the kind of sediment may signal a switch in the river's past source. Changes in particle size may signal a shift in the river's power or suggest that an earthquake shook landslide debris into the river bed. Visible tilting or deformation may signal more gradual movements of faulted rocks below. Together, these records can signal the past location, timing, and magnitude of multiple hazards and their underlying mechanisms.
The advantage is that the record of this tectonics is in the sediment. Because of this rapid subsidence, things are happening, the sediments respond, and they're buried so they're not eroded, so the evidence is still there. Of course, it's underground, so it's not easy to access.
To get at the deeper sediments, part of the team, led by Vanderbilt University, is drilling some 250 boreholes across the countryside using traditional Bangladeshi well drilling methods. Drillers start a hole and supply water for lubrication. Then they set up a bamboo frame lever attached to a vertical pipe. They raise the pipe up, then let it drop repeatedly. Bangladesh has hardly any rocks to get in the way, so with every drop, the pipe goes in further. When the pipe is nearly submerged, the drillers just screw on another section and keep going. Using just their hands, these men can drill 300 feet in one day. The payoff: sediment-rich water shoots out the top. The team distills the solids as they come out. At the site, students sort out samples, cataloging them by depth and location for later mapping and analysis. In other sites, a team led by Lamont Doherty scientist Mike Steckler has fed fiber optic cables into deep boreholes. These will record in real time the movements and compaction of built-up sediments. Bangladesh is severely endangered by climate-induced sea level rise, but in fact, it appears that much of the land is currently sinking faster than the sea is rising. This could worsen the effects of climate change and contribute to river course shifts, displacing millions of people. Along with natural processes, increased pumping of groundwater and building of dams upriver could play roles in the sinkage. This part of the study is applicable not only here, but in places like the Mississippi River Delta, where similar processes may be taking place. Local people with hard-won knowledge of many seasons can add to the scientific data, and they can testify to the real-world consequences. With a better understanding of Earth's movements past and present, maybe Bangladesh can design infrastructure and policies to help its people remain resilient.